Okay, so for video watchers, we started off by plugging in these x values. We got some y values to this equation here, and we graphed it. This is a quadratic equation, and the graph is what's known as a parabola. And now we're going to begin our thing. So we're in Unit 3, guys. Unit 3 is going to be all about quadratics. And in fact, Unit 4 will be about quadratics also. We will. This is lesson 1.
I don't know, it's Friday, right?
Lesson 1 is all about graphing quadratics.
Oh, it's objective? It's objective. Oh my god. That's objective. That's objective. It's a math joke, guys. Get it? Objective, you're up. No, I'm just kidding. No, I didn't.
I'll pause for a little while. So just so you guys know, in this chapter of quadratics, we're always focusing on quadratics that look like this. Quadratics have another form called standard form. We're going to focus on that in chapter 4, okay? And that's pretty much it. So today we're going to be graphing them when they look like this. Now we've seen something that looks a lot like this before, right? That's when we were talking about graphing absolute value functions. And a lot of it's pretty similar. So let's go ahead and start off there then. So part A, let's review some stuff here about transformations and whatnot. All right, so we know what a quadratic looks like. A quadratic looks like a U shape, right? Now absolute values look like a V shape, right? But just like a absolute value, it has a vertex. So guess what? H and K are still the vertex. And the same thing applies to these numbers as it did with absolute values. Remember guys how we took this number and we changed the sign of the H? Yes, Mr. Raymond, we remember that. Yeah, that's right. We do the same thing here. And that's going to tell you what your vertex is. Okay? Now, last time when we did absolute value, this number was our what? Slope. That was our slope. Now, we can't really call that a slope this time. And let me tell you why. The reason we can't call that a slope is because when you're talking about an absolute value function, the rise and run never changes. It's always over and up the same amount, and therefore you end up with a straight line. But with absolute value functions, they curve. And so here I go over this much, I go up that much. But the next time I go over that much, look at my rise. It changed a whole lot. Next time I go over that much, I can't even reach it now. So the slope is constantly changing on a quadratic function. So we can't really say that that's the slope. So what we're going to do instead is we're going to say, well, a lot of the things we learned about transformations still apply. So for instance, draw a little arrow here. We're going to make a box, but first of all, let's do this. If A is positive or negative, you guys remember what happened to the V shape when it was negative? What did it do? It flipped upside down. Same thing, Anna. No phones right now. Huh? Tell her that you're learning and then get that conversation over. Right now you need to focus on that. So same thing applies here. When A is a negative number, you're going to have a sad face parabola. When A is a positive number, it's going to be a happy face. Okay? Now let's talk about some more stuff here with the A. You guys remember what happens when you have a function and you don't write this. I just want you guys to reflect with me for a minute here. Do you guys remember what happens when you multiply it by a number bigger than 1? it gets stretched. Okay, so the same thing happens here. So if we're multiplying this x minus h squared, if we're multiplying that by something that's bigger than 1, then it gets stretched. So I'm going to turn this into a table now. So if the absolute value of a is greater than 1, that means we don't look at the sign of the number, just the number itself. But if that number is bigger than 1, then it stretches it. So if it's positive and bigger than 1, then it looks like this. It gets stretched long, and it still goes up. But if it's a negative, like let's say it was a negative 2, it's still getting stretched because it's a 2, but since it's negative, it's upside down. Do you guys remember what happens if you take a function and you multiply it by something less than 1? It compresses it, smashes it. In this case, what it's going to do is it's going to make your parabola look really fat and wide. So for instance, if the absolute value of this number is less than 1, then it's either going to look like a really fat little smiley face or a fat sad face. Okay? Over here, this is a normal looking parabola. So it's going to be like a normal size shape. Normal, whatever that means, right? Anytime a equals 1. So if a equals 1, we're going to call it normal. If a is greater than 1, we're going to call it stretched and skinny. If a is less than 1, like a fraction or something, it's going to be wide or compressed. Okay? So we can't really just go over and up anymore. It actually could work for some problems, but for the most part, this is probably a better way to go about it. This always works. And then we have our vertex. So let's go ahead and put this to work for us here. We're going to go ahead and graph some of these things now. So let's do an example. Hey, Mark. So guys, I'm going to be showing some work here, and I would encourage you guys to write it down as well. But you don't actually have to do that when you're doing your homework and stuff. It's just nice to have it in your notes so you know how we got from this to the graph. Yeah, sure. So the first thing that you're going to want to do, guys, is you're going to want to identify what your vertex is. That's the first thing you want to do. All right? So the vertex, in case you forgot, is this number here in the parentheses next to the x goes here, and the number out here goes there. And you have to remember that for this number, the sign, what?
Oh,
it
shoot,
changes.
You could just write in parentheses -8 for when it's still variables.
So long as you know to change it, I'm good.
Yeah.
Yeah, however you want to represent it is good, as long as it makes sense to you. All right. Now, the next thing I'm going to ask you is for this number. Is this number positive or negative? Let's draw an arrow to here. Okay, so that's our A number. Now, when A is positive, what do we know about our parabola? No.
It goes up.
It's a happy face, is how I'm going to say it. And when A is negative, it's a sad face. Right? So in this case, do we have a happy face or a sad face?
Or a rainbow. Oh, it looks like a face.
It does. A little alien face.
Weird.
It's a clown.
All right. Let's do letter C. Let's do letter C. Okay, now, after you determine what the vertex is, whether it's a happy face or a sad face, next thing you want to decide, is it wide
Or compressed.
stretched, or is it normal? And actually, we're going to look at the same number here, 3. Now, is that number, if you take the absolute value of that number, what's the absolute value of 3? Now, is 3 greater than 1 or less than 1? And when it's greater than 1, what is that? Now we say stretched. So if the number is bigger than 1, it's stretched. If it's less than 1, it's going to look flat, like or wide. Okay? So once you have those 3 things in place in your mind, you're ready. Like I said, you don't have to write this out in your homework. You could probably do all that in your mind. But once you have those 3 things in place in your mind, you're ready to graph it. Ready? So we're going to start by plotting our vertex. My vertex is 2, 1. Over 2, up 1. And now I'm going to put a U shape on here. My U shape is going to be stretched up. Ready? Try to make it look skinny. We're not being very precise here. Now we could get more precise. We could plug in some x values and find some specific points and get it more precise, but I don't think we need to do that. So long as you know it's stretched and up, I'm good. Okay? So that's how we're going to graph these quadratics. Bueno?
Sí. Sí, bueno. Yes.
I'll leave it up there a little longer for you there, Michael. I'm going to write a new problem up here, though. And this time I'll let you guys kind of walk me through the process a little bit. Let's get a little more creative in this. So let's call this number 2. Okay, so the first thing we want to do is we want to find our vertex. So I'm going to give you guys about maybe 20 seconds. Figure out what your vertex is. If you want to ask a neighbor, go ahead. But I'm calling you about 20 seconds. Something like that. Okay, so I'm going to ask Eric, what's my vertex? Okay. Okay. Augustine? Not sure? Okay. Let's try one more person. Let's try, no, David's not here. How's about Gabby?
The vertex?
Yeah. So remember, this number goes here, but you change its sign. This number goes here, and you don't change its sign. So there's your vertex. All right. Next thing I want you guys to do is I want you to decide, is it happy face or sad face? So don't say it out loud. Just take a moment. Talk to a neighbor if you need to. What do you think, Henry?
It's going to be the negative one? Right.
Well, you're right, but I'm asking a different question. I want to know, is it a happy face or a sad face?
Oh, I'm sorry. Happy face. Right now.
It's a sad face. Because my number here is a negative, so therefore it's going to be a sad face. All right?
This is going to be sad face.
Yeah.
Isn't the one a positive? I'm sorry, I wasn't looking at the right one.
You change the sign of that number. All right, let's ask, the next question will be, why is stretch or normal? So take a moment to see if you can figure that out. What do you think, Miss Kayla?
It would be wide.
It would be wide? Because we take this number again, the one in the front, we take the absolute value of that, what's that? It's just a positive, right? And then, is that less than 1 or greater than 1? Less than 1, and when it's less than 1, it's wide. Okay? So now we get to graph it. So if you guys want to try to graph it really quick, I'll give you a pause. Okay? So I'll let you guys compare your answers with mine here. The vertex is -1, -3, which is right here. And it should be a wide, sad face parabola. No. Yeah. Just so long as you know it's wide, I don't care how wide you make it. The reality is, the smaller this fraction is, the wider it gets. Okay? But we're not being that specific. All right. So, I want to do another one thrown at you here before we begin. Let's do number 3. So write down these two problems, but leave enough space so that you'll be able to graph them however you choose to do that. So now what you guys will notice is that we're missing some numbers here, right? We know it's supposed to have an A times x minus h squared plus k equals y. So we only have 2 numbers up here though, right? So, but we need 3, so we're missing 1. So let's figure this out. What is the 5? Is it the first, middle, or last? It's our A, so let's put that there. What's this 3? Is that the middle one or the last one?
No.
It's going to be the last one. You want to know how I know? It comes after the square. So here's my square. So this minus 3 goes here. So what am I missing? We're missing the h, right? The middle one. Do you guys remember what that would be if you're missing it? It's 0. Okay, so we might want to make a note here. If you're missing, and this applies to k as well, if you're missing h or k, they equal 0. Okay, so if you're missing either this number here or this number, then you can put a 0 there. Now you don't have to write it. If you could just do that mentally, I'm fine. But I'm writing it out for you guys. Okay, now this one, once again, we should have 3 numbers, but we're missing some stuff. So, all they gave us really was a 1 here. Where does that 1 belong?
In the middle.
That one goes right in the middle, right? That's good. So we're missing the A and the K. Now what I just tell you K would be if it's gone?
0.
So that's going to be a 0. But A, I didn't tell you that would be 0. That one's going to be a 1. But you notice the negative there? So it's actually going to be a -1. Okay? So that might be another note that you want to write to yourself. If A is missing, it equals 1. Okay. I feel like maybe we should do these together a little bit more. How many of you guys feel like you could just knock this out right now and do it? 1, 2, 3. That's a pretty good number. How many of you guys feel like we should maybe go through it a little bit more before I set you loose on doing it? All right. Well, all right. Well, why don't we try it out? Why don't you guys graph these and we'll see how you do. Go for it.
Bailey, I just wanted to hear my voice when I go home.
So let's go over these real quick. Natalie, what's your vertex for this one?
But it would be negative.
The 3 stays negative. You only change the sign of the one inside. Javier's not with us, but let's try Vanessa. Oh, Rowan. Hello. Happy face or sad face? Yes. Since this is positive, we have a happy face. Guys, can I have all side conversations stop at this time? We're going to go over these. You guys should be checking your work right now. Alexis. Henry. Supposed to come back. So, what did I say? Alexis, wide, stretched, or normal? Since this is greater than 1, it's going to be stretched. All right. So if you guys were to graph it, 0, -3 would be down here, and it's going to be upwards and stretched.
Wait, how do you know it's like that? Oh, wait, there's no other points, just that. Oh, okay.
I don't know what that meant.
No, because like usually there's a point here, and there's a point down you can connect. My bad, I'm just kind of really slow.
All right, so Danielle, what's our vertex on number 4?
-1, 0.
Yes. And I shall ask Heidi. This is negative. Is that going to be a happy face or a sad face? Yeah. Okay. Nathaniel?
Yes.
Wide, stretched, or normal?
Normal.
The reason it's normal is because this number is equal to 1 if you take the absolute value of it. So it's normal. So it's not going to be wide, it's not going to be stretched, it's going to be normal. So if we graph this, -1, 0 would be here. It's going to be a sad face. It's not going to be skinny, it's not going to be fat, it's just going to be like a normally shaped parabola. Okay?
Woo, it's called a day.
No.
I think we just need to.
All right. If you feel like you want some more practice, I'll put another problem up for you guys to try. And if you feel like you've got it down and you're good to go, that's it.
This is just